Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 4 variant 2 for Cambridge IGCSE Physics. We will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these exam questions. Let's study together, let's improve together. In today's lesson, we are talking about May June 2023 paper 4 variant 2. Total time for this exam is 1 hour and 15 minutes and you need to answer all questions on this paper. And total mark for this paper is 80. Question 1 part A says figure 1.1 shows a helicopter which is stationary at a height of 1500 meters above the ground. For part A1 we need to state two conditions necessary for the helicopter to remain in equilibrium. So simply we need to understand what is meant by equilibrium. Body is in equilibrium if resultant force on body is equal to 0. So first condition, simply you can say resultant force in any direction. Proper way to say is resultant force in any direction is equal to 0. And the second condition is resultant moment about any point is equal to 0. Resultant moment about any point is equal to 0. So these 2 points you have to write down. So condition 1, condition 2. If you want to write down here, simply you can say resultant force is equal to 0 at IGCSE level. If you simply write down resultant force is 0, 1 point, you can say resultant moment is 0. You will get 2 points. Means you will get 2 marks. Resultant moment is 0. But the proper way to state this one is resultant force in any direction is equal to 0 and resultant moment about any point is equal to 0. So if you write down these 2 points, you will get 2 marks. The first mark is B mark, means this has to be in your answer, and this is also B mark. This has to be in your answer. Second part says the mass of the helicopter is 3200 kgs. Calculate the change in the gravitational potential energy of the helicopter as it rises from ground to 1500 meters. So ground we can take our reference point, means h is equal to 0 here. So in this case the change in height, so simply then we can say change in height in this case is equal to delta h. We need to calculate change in GPE, so we can write down delta GPE. This will be equal to mg delta h, change in gravitational potential energy. So this is the change in gravitational potential energy. Mass of helicopter is given to us, that is equal to 3200, and value of g we can use 9.8, and the change in height we have, that is equal to 1500 meters. Now if we simply multiply, we will get our final answer is 4.7 times 10 to 7 joules, or we can say this is equal to 47 megajoules. So we can say 47 megajoule, because 4.7 times you can say 10 to 1 times you can say 10 to 6. So 4.7 multiplied by 10, we will get this is 47, and 10 to 6, this is mega. So it means this is 47 megajoules. And this question has 2 marks. You will get 1 mark if you have written this equation. You will get 1 C mark. If you got the right answer, you will get 2 marks. Part B says figure 1.2 shows a vertical speed time graph. Vertical speed time graph simply means that we are talking about vertical motion only. So we are talking about vertical motion only. For a parachutist who jumps from a stationary hot air balloon, the parachutist jumps from the balloon at time t is equal to 0 and reaches the ground at B. The point A indicates when the parachute opens. On figure 1.2, label a point on the graph where acceleration is 0 with 1, negative with 2, decreasing with 3. So first thing you need to understand, we have speed time graph. So what is the gradient of this one? So this is the key concept you need. Gradient of VT graph. So what is gradient of VT? V against T graph. gradient is equal to acceleration. So this is the key concept you need to answer this question. Now if you look at the initial part here, first of all let's try to find out 0 with 1. 0 means that gradient is 0, because gradient is equal to acceleration. Acceleration will be 0 when gradient is 0, and gradient is 0 at this point. You can mark 1 here, you can also mark 1 here, because gradient is 0 here. So we can mark here, you can also mark here, so it is also correct. Anywhere you can mark on these 2 points. Negative with 2, negative where acceleration is negative means where gradient is negative. If you look at this part, gradient is negative, so we can mark 2 here. So this is negative acceleration. Decreasing, so you can say gradient is decreasing, so it means acceleration is decreasing. So we can mark anywhere here. So this is the third point. So this is third point, you can mark this is as 1, and this one you can mark as 2. So this is how you can mark. Second part says explain in terms of forces the changes in motion which occur from when the parachutist leaves the hot air balloon until point A. Until point A means until this point. And parachutist opens parachute at this point. Parachute at this point. So we have to talk before opening the parachute. So let me mark here open parachute here. Question is asking us to explain the motion before opening the parachute. Open parachute, so we can write on here. So important point, so open parachute at this point. So we have to talk before this point. We can also draw the line here. We have to explain until this point. Until this point. So simply let me draw this line here until this point. So first of all, if you look at this point, when this person jumps out of plane, we can write down here person jumps out of the plane. So you can simply imagine this is the person. So when this person jumps out of the plane, initially the force acting on this person is mg only. So is mg only. As the resultant force on the person is weight only, there will be no air resistance initially because the speed is 0. So acceleration of this parachutist initially, this is downwards, and this acceleration will be equal to g. So we can say will be equal to g because resultant force is mg. When this person start falling downwards, air resistance on this person will start increasing because the speed of the person is increasing. So air resistance will start increasing, but weight of the person will not change. So now we can write down here. Let me write down first of all here. Here we have F net, that is equal to mg. So we have ma, that is equal to mg. So from here we can say a is equal to g. So this one is the initial acceleration as we mentioned here. Now in this case here we have F air, so this is air resistance. So how about resultant force now? So we can say this is case 1 and this is the second. So in this case F net we can write down here F net, this one has to be equal to mg minus F air, and I hope now you will see that this F net is lower than mg because this term is subtracted. So due to this term F net is lower. If F net is lower, how about the acceleration? So F net is equal to ma. So if F net go down, mass will not change, so a also will go down. So now we can go to the third stage. Third stage, when these two forces are equal, so I will be using red color. So at this stage when mg is balanced by F air, mean these two forces are equal, so F air. So we can write down the third case here now. For the third case we can write down F net, this is equal to mg minus F air, but F air in this case, so let me write down here F air, this is equal to mg. So we can write on here this is mg, F air is equal to mg, so it means F net is equal to 0 because this one cancel. So what does it mean? It means acceleration is also equal to 0 at this stage. So we can say acceleration also equal to 0. So it has reached the terminal velocity. Mean after you can see this gradient is 0, it means it has reached terminal velocity. So it has reached terminal velocity. Now let me explain you a little bit more about this. So if we start from here, you can see F net. If we compare this F net with this F net, you see F net is decreasing. It keep on decreasing. Finally F net becomes equal to 0. So if F net is decreasing, it means acceleration also keep on decreasing, and finally acceleration is equal to 0 and body reaches terminal velocity. So these points you need to understand, and these points you have to write down in your answer. Now let me show you the answer, how you can write down your final answer. In your final answer, you have to mention these points. You can say, first of all, initially there is acceleration due to weight only. So we have seen resultant force initially is equal to mg, so A is equal to g. Then A resistance increases, as we have discussed here. A resistance increases as speed increases. As A resistance increases, resultant force decreases. We have discussed this point here. Finally, when A resistance is equal to weight, mean A resistance is equal to weight, speed becomes constant, or it has reached terminal speed. So speed becomes constant, mean it has reached terminal speed. And this question has 4 marks. If you have written these 4 points, you will get 4 marks. Question 2 says a student catches a cricket ball. The speed of the ball immediately before it is caught is 18 meters per second. The mass of the cricket ball is 160 grams. Calculate the kinetic energy stored in the cricket ball immediately before it is caught. For this question, simply we need to calculate kinetic energy. So first of all, we need to understand kinetic energy is equal to 1/2 mv square. For this question, we have mass of the ball, that is 160 grams. So we have to convert this one into kilograms. So we can write on here, we have 1/2 and mass is 160 grams. So we need to convert this one into kilograms. So we have to multiply with 10 to minus 3. So we can convert this one into kgs. And the speed is given in meters per second, so this is 18 square. Now if we simplify this one, our final answer will be 26 joules. So this is how you need to answer. This question has 3 marks. The first C mark you will get if you have written this formula, and the second C mark you will get if you have plugged in these values, and the last mark is the answer mark. If you got right answer, you will get 3 mark. Part B says it takes 0.12 seconds to catch the ball and bring it to rest. Calculate the average force exerted on the ball. It is given to us that initially ball has speed u, that is equal to 18 meters per second, and finally its ball comes to rest, meaning the final velocity is equal to 0, and the time taken between initial velocity and the final velocity is given to us. The time taken delta t, this is equal to 0.12 seconds. We need to calculate average force exerted on this ball. F is equal to delta p over delta t, means the net average force. So delta p is equal to m times delta v divided by delta t. Mass is given to us, that is equal to 0.160, and the change in velocity we have, so we can write down 0 minus 18 divided by delta t, that is 0.12. So in this case, we will get answer that is equal to 24 newtons. This negative sign simply telling us that force is applied in opposite direction of motion of the ball. And question is simply asking us the force, magnitude of the force, so you can say 24 newtons. So this is how you can approach this type of problems. For part C, it is given to us as the student catches the ball, she moves her hands backwards. I mean, catch the ball like this and move the hands like this. Explain the effect of this action on the student hands. Why student when catch the ball move the hands back? So what is effect of this action on hands of the students? So for this purpose, we need to understand delta p, this is equal to F times delta t. change in momentum is the same. Change in momentum is the same because ball has initial velocity here and final velocity 0 and mass is constant, so this quantity delta p is constant. So if student increase the time taken, mean increase this time taken, let me use the red color. If we increase this time taken, we can reduce the force. So that's the point you need to understand. So simply we can say force decreases on the hands of the student. So simply you can say force decreases as time increases, or you can say longer time. So if you write on this one, you will get 1 mark. This question has only 1 B mark. That's all for today's lesson. I hope this lesson was helpful and you have improved your understanding of mechanics. If these videos are helpful, please like and subscribe because your encouragement is very important. And if you need more help and you want to support the work I'm doing on YouTube, please join Patreon. On Patreon, you will be able to contact with me directly, and also you will be able to ask me more questions on Patreon. And the link for Patreon is in the description of this video. And the solution of remaining questions from this paper I'll be uploading as soon as possible. See you in next video.